We have long believed we knew our neighborhood: 4 rocky sentinels, 4 gas giants, and a scattering of icy debris. But in the silent, frigid reaches of the Kuiper Belt, hundreds of astronomical units from the sun's warmth, the math no longer adds up. Look closely at the extreme trans-Neptunian objects, or ETNOs. They move as if they are being herded. Their orbits are not random, they are physically constrained, tethered by a massive invisible shepherd. This is the ghost in the dark, a gravitational anomaly 5 to 10 times the mass of Earth, patrolling the abyss between 400 and 800 AU. We called it Planet 9. We expected to find a super-Earth, a freezing world of rock and ice. But the more we look, the more we find nothing. For years, the world's most powerful telescopes have scoured the predicted orbital path. If Planet 9 were a standard world, it would reflect a minuscule amount of light. It would radiate a faint heat signature. Yet the deep field surveys remain stubbornly blank. We are faced with a disturbing astronomical paradox. The gravity is undeniable. The presence is felt in the very trajectory of every icy rock in the outer rim. Yet it possesses no surface. It reflects no sunlight. This is not a failure of our technology, but perhaps a failure of our imagination. What if we haven't found a planet because we are looking for something that isn't a planet at all? In 2019, a radical hypothesis emerged. What if the shepherd of the Kuiper Belt is a primordial black hole? This is not the stellar mass titan born from a collapsing star. This is something far more ancient. If we take the predicted mass of Planet 9, let's say 5 times the mass of Earth, and compress it into a singularity, the result is hauntingly small. Using the Schwarzschild radius formula, we define the event horizon, the point of no return, a mere 4.5 centimeters. For a body 5 times the mass of our planet, the radius is a mere 4.5 centimeters, physical no larger than a grapefruit. A gravitational monster capable of bending the orbits of entire worlds, yet physically no larger than a grapefruit. It is the ultimate camouflage. Unlike the black holes we observe in distant galaxies, a primordial black hole was not born from a dying star. It would have formed in the chaotic, high-density fluctuations of the very early universe, mere fractions of a second after the Big Bang. These ancient remnants could have wandered the cosmos for 13.8 billion years. One such wanderer, passing through our solar system's infancy, may have been snared by the sun's gravity, settling into a permanent, lonely patrol. A relic of the beginning of time, hiding in our own backyard. If it is a black hole, how do we prove it? We cannot see the object, but we might see its breath. Primordial black holes are theorized to be surrounded by a halo of dark matter. As this dark matter is pulled into the singularity, particles may collide and annihilate, releasing a faint but distinct annihilation signal. Furthermore, if a small asteroid or a stray comet were to be captured by this tiny giant, the tidal forces would shred it, creating a brief, high-energy flash. A flare in the darkness that would confirm the impossible. We aren't looking for a planet, we are looking for a spark. It is a humbling realization. We have mastered the atom, walked on the moon, and peered into the dawn of time. Yet, just past the edge of our vision, a dark remnant of the Big Bang may be guiding our fate. Whether it is a frozen super-Earth or a primordial singularity, the message is the same. The universe is under no obligation to be visible. We live in the presence of giants, some made of rock and some made of nothingness.